just picking up where we left off from yesterday on notes. So, doesn't simplify? That's not overly helpful. If it doesn't simplify, Liam, what does that mean about my graph? If it doesn't simplify, there's no holes in the graph. Okay, so we don't have to worry about that. Lenora, where do I go next? I go to find the vertical asymptotes. Alex, how the heck do I find the vertical asymptotes?
You take the positive denominator and you equal it to 0.
Now, in this case, does it matter if I do the original or the factored form? No, you'll get the same answer. Now, if you choose to do the original for some reason, or sorry, the factored form is what I meant to say. For some reason, people get stuck on what to do here. Remember, when you're doing a factored form, you split. That does not mean x is 2. That means 2 is 0. Is 2 ever 0? If I get 2 minus x equals 0, what does that mean x is? X equals 2. Subtract 2, divide by the negative 1, ta-da. Jack! Now what? I find the horizontal asymptotes. Beta! How? Yeah, it's the most complicated part. Okay, most complicated is the wrong statement, but it's the weirdest part. We look at the degrees. Miriam, what's the degree of the numerator?
1.
Beautiful. Isaiah, what's the degree of the denominator? 1. Sorry, I didn't hear you if you answered already. I think 1 is equal to 1. That's what I'm thinking. Wendy, what's that mean about horizontal asymptote? Leading coefficients get divided. Exactly. Burton, what are my leading coefficients?
Is it 5 and 2?
So close.
5 and 4.
Further away.
And then -2.
There we go. Don't forget your negative. So, leading coefficients are the coefficients of the term with the exponents. Make sure you're going back to your original, not your modified. 5, -2. 5 divided by -2. I am okay you writing decimals if you don't need to round. Can y'all write it without having to round? Is 5 divided by 2 a nice number? Ish. Nice decimal. Yeah. It's -2.5. Me, personally, you'll see it, I'll write it as -5/2. Kylie. Right check. Do I need to check for oblique asymptotes? I can't hear you. No. If it has a horizontal asymptote, you do not need to check for oblique. It's impossible to have both. Okay. So Aubrey, what the heck do we do now? How?
With the vertical asymptotes in the graph.
Beautiful. Start with your asymptotes. Not only vertical, but horizontal. Okay, x is 2. X equals 2. Y is -5/2, which for the sake of graphing, think of it as a decimal. -5/2 is -2.5. Austin, now what? You put it into the calculator. Now, when I put it into the calculator, I have to be picky about how I enter things in. Because if I put 5x plus 2, divide symbol 4 minus 2x, just that, it will give me a linear equation with the y-intercept of 1/2 and a slope of 3. That's not going to help me. What do I need to do to put it into my calculator properly? Put parentheses, top, bottom, or both? Both. And do the original. The original should be the one that goes into the calculator. 5x plus 2, divide 4 minus 2x. Beautiful, love it. Looks like that. Kind of looks like a regular hyperbola just flipped over. Kinda being the operative words. Okay. That is similar to the ones we did yesterday. Today we're going to be stepping it up a notch. Today we're going to start coming across problems that have holes in the graph and oblique asymptotes. Now, holes in the graph you find by simplifying things out. We've already been practicing that. Oblique asymptotes you find by doing polynomial long division. It's been a minute, right? Since we've done polynomial long division. So, we're going to switch up the instructions for a little bit. We're going to do some division. I love polynomial long division. Have you not concluded I'm weird already? Okay, you want to do polynomial long division. First thing you're going to do is put the divide symbol. As in, like, this thing. What you're dividing goes inside. What you're dividing by goes to the left. But make sure you're not missing any terms. Make sure it's in standard form. Okay, here's what I mean by that. Missing terms. It better decrease in degree from term to term by 1. The exponent better decrease by 1. Does it do that? Yes. Biggest exponent always first and decrease by 1 as you go through. It does do that. So I put that inside. I put this to the left. And now I got to figure out essentially what multiplies by something to get something else. Specifically, you're going to look at the first term of what you're dividing by, in this case just the x. And you're going to ask, what do I have to multiply by x to get the first term of what's inside? What do you have to multiply by x to get an x to the third power? X squared. The answer to that question goes above. Once we have that, we're going to have to distribute that x squared into this. So, if you had me last year in advanced algebra, you saw me always do this. X squared getting multiplied by x plus 9, and then I said it goes over here. stacking like terms. Do you have to write this over to the side? Absolutely not. Do I recommend you do it for your notes at least, just to see where things came from? Yeah. In case you aren't 100% perfect at recalling long division. What is x squared times x? X cubed. What is x squared times 9? Plus 9x squared. And then, when you're doing long division, after you do that, the next thing you do is subtract. The first term should always cancel out. If it doesn't, you've done something wrong. X cubed minus x cubed. Gone. 13x squared minus 9x squared. 4x squared. Is this looking familiar? You did it last year. Bring down the next term. Or if you want to bring them down both, you can. Generally, you just bring down one at a time. But you can always bring down the entire problem of what's left. Once you get here, you repeat the process. You ask yourself about the first term, multiplying by something to get this term. What do I multiply by x to get 4x squared? 4x specifically. I put whatever it is up here. Don't forget the plus or minus. And then, whatever it was, 4x in this case gets multiplied by what you're dividing by x plus 9, and that goes underneath. Repeat the process until you run out of terms to make it work. 4x times x is 4x squared. 4x times 9 is positive 36x. Remember, you are subtracting. Be careful with your positives and negatives. 4x squared minus 4x squared, does it cancel? Yes, we did something right. 40x minus 36x. Four x. Pull down the next term. Isn't it? What do you multiply by x to get 4x? 4. Plus 4. And the 4 gets multiplied by the x plus 9, and I get 4x plus 36. And when I subtract, that cancels, and I'm left with 10. This has fewer x's than what I'm dividing by, so I can't actually divide it. This is the remainder. Now, the remainder traditionally gets turned into a fraction as that number over what you're dividing by added to the thing. That being said, today we are ignoring the remainder, because when you find an oblique asymptote, you do long division without the remainder. We're going to do one more like this, and we're going to talk about something else related to this as well. Before we get back to our actual graphing. Okay, I'm dividing. Put my big old divide symbol. What goes inside? Yes-ish. That's the part that goes inside, but is it decreasing an exponent like it's supposed to be? No, what's it missing? It's missing a regular x. Okay, if I asked you, how many regular x's does it have? What would you tell me? None or 0. So it's kind of like having a 2x squared plus a 0x plus 5. Would you agree? That's what goes inside. If you have any missing terms, you need to put them in as zeros. Then we continue the process the way we did above. What do I multiply by x to get 2x squared? 2x, put that up top. And remember, distribute through. After that, we subtract. 2x squared minus 2x squared will nicely cancel out. 0 minus a negative 6x. Please be careful of that. What is 0 minus negative 6? Positive 6. And then x multiplies by 6 to give me 6x. When we subtract, be careful of your negatives. We will get 23 here. Now that is the remainder. As soon as this has fewer x's, that is the remainder. The key thing we're going to be looking for in here is without the remainder. Is there another way to divide polynomials? One more thing related to polynomial long division that I want to remind you of is there is also synthetic division. Now, synthetic division doesn't always work. You have to be dividing by something that is of degree 1 of leading coefficient 1. I'm divided by x minus 3. Does that have degree 1? Does that have leading coefficient 1? Yes. There's also synthetic division. Synthetic division was where you had the little box and you had the line that went all the way across. Inside the little box was the opposite of the number in the denominator. That was negative 3, so in here I put positive 3. And then across next to it, you put all of the coefficients from the top, including the zeros. It went 2, it went 0, it went 5. Synthetic division works just as well. You pull down the first term, and then it goes multiply, add, multiply, add, multiply, add. Multiply these. 3 times 2 is 6. And then we add. And we get 6. Multiply again. We get 18. And then we add. And we get 23. The first term is always the term that has an exponent 1 smaller than what was in the numerator. Since the numerator started with a squared, this one starts with just a regular x. Hence 2x plus 6, and then this last one was the remainder. I don't care if you do synthetic division or long division, just make sure you're only doing synthetic when you actually can do synthetic. It's why I don't go into it quite as in depth, because it doesn't always work. Ready to get back to some graphing? No, that sucks. Time to get back to some graphing. Now, just like before, I'm going to assume that we label all of the important parts. I'm just not writing that in the instructions. First thing we do is we try to simplify. In order to simplify, I need to factor. Can I factor the top? Two things that multiply to 2 and add to 3? 2 and 1. Can I factor x plus 1? No. So I put it in parentheses. Will it simplify? Yes. This time it will simplify. Anything that simplifies is what's going to lead to a whole. In this case, it's the x plus 1s. So to get the whole of the graph, I set what canceled out equal to 0. X plus 1 equals 0 gives me x is equal to negative 1. When x is negative 1, there will be a hole in my graph. After we check for simplifying, what's the next thing we check for? Vertical asymptotes. I set the denominator that didn't cancel out equal to 0. What part of the denominator did not cancel out? That's not denominator. 1. Is 1 ever going to be 0? There's no vertical asymptotes. If I check horizontal asymptotes, my degrees are 2 and 1. If the degree of the top is bigger, what does that mean? No horizontal asymptotes. If there's no horizontal asymptotes, I check for oblique asymptotes. Oblique asymptotes require long division. They occur when the numerator is 1 higher than the denominator in degree, but the denominator doesn't cancel out completely. Is 2 exactly 1 higher than 1? Yes, that feature is met. Did my denominator cancel out completely? Yes. So while it fits the m equals n plus 1, denominator disappeared. Which means there's also no oblique asymptotes. This graph does not have a single asymptote to it. It only has holes in the graph. Now here's the thing. I can go through and I can go to my graphing calculator and I can type it in and do all that wonderfulness. Don't forget to put parentheses around the top and the bottom. But I don't have to either. Here's why I don't have to. My graph simplified down to x plus 2. What type of equation is x plus 2? Linear. How do you graph a linear equation? How do I graph y equals 2x plus 2? Sorry, x plus 2. You start with the y-intercept. What's the y-intercept of x plus 2? 2. What's the slope? 1. How do I move with the slope of 1? Rise 1, run 1. Rise 1, run 1. A graph looks like this, almost. You could have done that in your calculator. There's nothing wrong with doing that in your calculator, but it's just faster, especially for me not to. If you struggle with linear graphing, then maybe it's not faster for you. There's one thing I haven't put in the graph though. The whole. The whole is missing from the graph. Now the whole occurs where x is negative 1. Now if I look on my x-axis, x is negative 1 right here. The graph would have x at negative 1 right here, because that's what's directly above negative 1. Right here, there is a hole in the graph. So I just draw a big open circle right there. And I call it x equals negative 1. Okay, got one final example for y'all. By the way, remember what's happening tomorrow? Work day. No new homework tomorrow. Skill builder tomorrow. Okay, now this last one, I want some room to write. I could maybe fit it here. That wouldn't be a problem, but I don't want to try. J of x is equal to x cubed minus 1 over x squared minus 4. Can I factor x cubed minus 1? Actually, yes. It's a difference of perfect cubes. Now here's the thing. Do you think I'm going to give you a bunch of difference of perfect cubes on the homework? No. We didn't talk about difference of cubes and factoring for a reason. It's not going to come up often enough for you to see it. The only time you're ever going to actually see it is in notes. Just because I like it as a good problem. Difference of cubes factors into a binomial and a trinomial. The binomial starts with what was cubed, x, and what was cubed. What number cubed is 1? 1. Okay, the trinomial starts with what was cubed but squared. X was cubed, square that, and you get x squared. It ends with the second thing that was cubed, but then you square it. 1 was cubed, 1 squared is 1. And then its middle term has the two things that were cubed multiplied together. X times 1. X. Now as for signs, depends on if it's a difference or a sum of cubes, because both will factor. If it's a difference of perfect cubes, the binomial will have the difference. The first sign in the trinomial is always the opposite of this. If this was plus, this would have been plus, and this would be minus. But since this is minus, this will be plus. And then the other one is always plus. Do you need to memorize all that? No. Did I factor it anyway? Yes. Can we factor x squared minus 4? That one we should know. It's a difference of perfect squares. First thing squared was x, Second thing squared was 2. One's a plus, one's a minus. Something that is a difference of perfect cubes will never factor further. So x squared plus x plus 1 is not going to factor. It's impossible. Will this simplify? No, which means what about our graph? There's no holes in it. Move on to the vertical asymptotes. I set denominator that didn't cancel out equal to 0. None of the denominator canceled out. I can go to this form and set that equal to 0. There's nothing wrong with that. I saw a couple people do that yesterday. They then solved by square roots. But you need to remember, if you solve by square roots, if you choose to solve this way instead of using the factored form, when you introduce a square root to the problem, what do you need to introduce with it? Plus minus. So x equals positive and negative 2. There's 2 vertical asymptotes, one at 2, one at negative 2. Horizontal asymptotes. My degree of the top is 3, the degree of the bottom is 2. When the degree of the top is higher, none. But that's when we check for oblique. Is 3 equal to 2 plus 1? Yes, there is an oblique asymptote. To find it, we do polynomial long division. Synthetic, if we can, do it. Can I divide using synthetic division when my denominator is x squared minus 4? No. It has to be both degree 1 and leading coefficient 1. That's degree 2. So I have to do full-on long division. When I do full-on long division, or synthetic for that matter, I need to make sure I'm not missing any pieces. Is my numerator missing any pieces? Yes, what's it missing? Both x squared and x. So, remember, this is x cubed plus 0x squared plus 0 x's. I'm writing off screen, don't mind me. And then minus 1. If it's missing terms, you need to add the zeros. That keeps our like terms stacked. Is x squared minus 4 missing any terms? Yeah, it's missing the regular x. So that's x squared plus a 0 regular x is minus 4. Now here's the nice thing about doing polynomial long division when graphing rationals. You get to ignore the remainder, which means you often get to stop dividing early, like really early sometimes. What do you multiply by x squared to get x cubed? X. That x gets multiplied by the x squared plus the 0x minus the 4. I get x cubed. I get 0x squareds. I get minus 4x's. Do not forget that you are subtracting at that point, and positives and negatives make a difference. X cubed minus x cubed cancels. 0x squared minus 0x squared, in this case, also cancels. It's kind of nice of it. It does good things when it does that. 0 minus a negative 4x is positive or negative? Positive 4x. Do you notice this has fewer x's than that now? That means it's the remainder. I don't care about the remainder. The moment you get to the remainder, you can stop. The answer, x in this case, or more accurately, y equals x, y equals that answer, is the oblique asymptote. I have my holes and my asymptotes all figured out, so I go to my graph. X equals 2. X equals -2. How do I graph the oblique asymptote y equals x? It's a linear equation. What's its y-intercept? Y-intercept should be the constant. Currently it's y equals x plus what? 0, which means the y-intercept is 0. What's the slope? 1, which means I'm going to rise 1, run 1. Once I have 3 dots, I got the idea of what my line is doing. And I graph it. Remember to label all of your asymptotes, which means I'm labeling this one y equals x. Once you have that, you can go to your calculator and graph. My graph appears to have 3 distinct parts. Does that make sense with 2 vertical asymptotes? 2 vertical asymptotes, part over here, part over here, part over here. That matches. If you think you screwed up on the long division, you can always put an oblique asymptote in as your y2. Does it appear like the graph is leveling out to that oblique asymptote? Yeah, which means I probably didn't screw it up. My graph is here a little bit, it's here, and then the middle goes like that. If I all of a sudden had done my long division and got an oblique asymptote like that, that would be a major red flag. It's not leveling out at that. That would be an indication to check my long division, and I will say, check positives and negatives, and you're subtracting first. Okay.